Today we're going to be solving trig equations. Our objective is to be able to solve a trig equation within a given domain. So what do we need to know about the unit circle to solve trig equations? Well, if you remember, we have all of our degrees, our radians, and then these ordered pairs. And you really only need to remember the first quadrant because remember, all of our values for our ordered pairs repeat. And then what you really need to be careful with is just what are our signs in each quadrant. So for example, our x and our y are both positive in the first quadrant and then so on. So we need to know what our values are, we need to know what our sign is going to be, either positive or negative, and then we need to know what our possible solutions could be for our angles. Meaning, what are our reference families? So we have these are our 30-degree angles, our 45, our 60, and then the angles that fall on the actual x and y axes are quadrantal angles, and we have 0 pi, pi over 2, pi, and 3 pi over 2. Now if you notice I didn't write 2 pi, I used 0 pi, and it's typically that when we get to our angle right here, we want to use the 0 and not the 360, so we're going to use 0 pi, not 2 pi. So we're going to go through 5 examples, and we're going to solve for our theta. In this case, we usually write x just because it's a little bit easier. So if you want to write theta, you can instead of the x, but I just wrote x for our worksheet. Okay, so if they say for theta, they're talking about the angle, which in this case is where the x is. So if we go through this, again, if I want to solve for x, just like any other solving, our goal is to combine like terms and try to isolate the x. So what I'm going to do is I'm going to see that I have 3 sine x and 5 sine x. So what I'm going to do is I'm going to try to move both to the same side, so that way I can combine my like terms. So what I'm going to do is I'm going to subtract my 3 sine of x, like terms, so I'm going to get 2 sine of x minus root 3 equals 0. And again, don't forget this equals 0. Most students, when they're solving an equation, just randomly forget this. Remember, equation means there has to be an equal sign in it. Now I'm going to, again, try to isolate this. So what I'm going to do is I'm going to add my root 3 to both sides. So if I do that, I'm going to get equals positive root 3. But again, my goal is to get x by itself, so I'm going to divide both sides by 2, so you can see that. So I'm left with sine of x is equal to positive root 3 over 2. But I want to solve for this. I want to get the x by itself. So what am I actually asking you to do? Well, to get that by itself, if you remember, we do inverse trig. So I'm going to do inverse sine of root 3 over 2. Now this is something that you guys have already been tested on, and you're trying to find out what angle has a sine value of root 3 over 2. Okay, so, or a y value of root 3 over 2. So what you need to know is this is positive. So where is sine our y positive? It's positive in quadrant 1 and quadrant 2. And that's from knowing where our plus and minuses are. Next thing I want to know is what reference angle has a y value of root 3 over 2? Well, that's our large number, so that's going to be our 60-degree family. So I'm looking at the 60-degree family in quadrant 1 and quadrant 2. And if you have those memorized, in quadrant 1, 60 degrees is pi over 3. In quadrant 2, it's 2 pi over 3. So those would be my 2 answers for x, or for my theta, my angle. Pi over 3 and 2 pi over 3. In this one, we're solving for tangent, or we're actually solving for x, but we have tangent squared x minus 3. Again, my goal is to isolate the x, so I'm going to try to move as much over to the other side as possible. So what I'm going to do is add 3 to both sides. But again, I want to get x by itself, but I have this squared, so what I'm going to do is take the square root of both sides. So I'm going to get tangent of x is equal to, and this is the important thing, plus or minus root 3. Okay, don't forget that because we're going to lose a lot of answers if we forget that. Again, I want to get x by itself, so to do that I'm going to have to take the inverse tangent of both sides, which would leave me inverse tangent of plus or minus root 3. Again, what is this asking? It's asking what angle, or angles, has a tangent value of either a positive root 3 or a negative root 3. Well, since I want positive answers and negative answers, tangent, remember, is our y divided by x. So when is this positive? Well, either they both have to be positive or they both have to be negative. Well, we have positive, positive in this quadrant, negative, negative in this quadrant. So these two, the diagonal ones, are where tangent is positive. Well, if I want it to be a negative, that means either y has to be positive and x has to be negative, or y has to be negative and x has to be positive in order to divide and get a negative answer. Well, that would be in these 2 quadrants. So anytime you have a plus or minus, you're actually going to get an answer in all 4 quadrants. But now the goal is to figure out, well, when is my answer root 3? So if we try to figure that out, remember tangent is y over x, okay, which really was root 3 over 2 and 1/2, because you remember that since all of ours are divided by 2, I could have simplified that out. So I want to know when is the y root 3 over 2 and the x 1/2. Well, again, that happens to be our 60-degree family. Okay, and they're not all 60 degrees, but this is just another way to show you how an answer can look different and we get the same thing. So I'm looking for the 60-degree reference angles in all 4 quadrants. Okay, and this is why it's important to remember those families. So all the 60s are pi over 3 in the first quadrant, 2 pi over 3 in the second quadrant, 4 pi over 3 in the third quadrant, and 5 pi over 3 in the fourth quadrant. Okay. Now, the reason I stopped there is because I'm asking for all of my answers to be between 0 and 2 pi, just our unit circle. If I had changed that and said, you know what, I only want to know from 0 to pi, I would have only given the first 2 answers, because those are the answers from 0 to pi. If I wanted to know from pi over pi halves to 3 pi halves, I would have just given these 2 answers, the 2 pi over 3 and the 4 pi over 3. So that's what we're talking about with domain restrictions. Now, typically, to make it easier, we just go 0 to 2 pi. When you get to pre-calculus, they might mess around with this a little bit more. They might ask for the general form, which means they want every single possible answer. So if you remember, coterminal angles are angles that have the same terminal side, okay, but we have a different number of rotations. Well, then that would look a little bit different, and that gets a little bit more complicated where you add, 2 pi n and things like that. But since we're not going to be talking about that in that class, I'm not going to go through all those examples to hopefully not confuse you. So let's look at our third example. Getting a little bit more complicated. If you see, I have 3 sine x secant of x minus 2 root 3 sine of x. So hopefully from doing all our identities, you can see that there is a sine of x in both of these terms. So I'm going to actually factor that out. So I'm going to factor out a sine of x, and that leaves me with 3 secant x minus 2 root 3 equal to 0. So if you remember from way back when we did solving by factoring, if I have 2 things multiplied together that equals 0, I can set the first term equal to 0, and I can set the second term equal to 0. This is just called the zero product property. Okay. And now I actually have 2 problems I have to solve individually. Again, I'm solving for x, so I'm going to take x equals the inverse sine of 0. So again, this is asking where on my unit circle, again because it's 0 to 2 pi, is the sine value 0. So let's think about that. We'll solve this one first. So when is sine 0? That means we did not go up or down. Well, that would be here and here, because this is, if you remember, 1, 0, and this is negative 1, 0. Sorry, negative 1. Okay, that looked like a 1. So, what are those 2 angles? Well, remember here, we're always going to use 0 or 0 pi. I like to put the pi to remind us that it's not a degree, even though we don't have the little circle. And then here is pi. So I actually get 2 answers, 0 and pi. Let's solve this one. Again, I want to get the x by itself, so I'm going to add 2 root 3 to both sides. I'm going to divide both sides by 3. I'm going to get secant of x equals 2 root 3 over 3. Now, secant is a little bit harder to deal with. It's nice to deal with sines, cosines, and tangents when thinking of the unit circle. So what I'm going to do is take the reciprocal of this. If I don't want secant and I want its reciprocal, which is cosine, so I just took the reciprocal of this side, that means I have to take the reciprocal of this side, which means I'm going to take the fraction and flip the numerator and denominator. But that doesn't look really nice. Okay, it looks a little messed up because I have this radical in the denominator. So what I'm going to do is I'm going to rationalize this, because I definitely know I have never seen that on the unit circle. So I'm going to get 3 root 3 divided by, okay, remember this is 3, so 2 times 3 is 6, which if I reduce, I get root 3 over 2. All right, well, we're seeing this a lot, but now I'm asking cosine. So what I now have, after this algebra, I have cosine of x is equal to root 3 over 2. Well, again, I'm solving for x, so I want to know when is x is going to equal the inverse cosine of root 3 over 2. Okay, so let's think about this. Cosine is my x value. When is x positive? X is positive in the first quadrant and in the fourth quadrant. So my 2 answers are going to fall in those 2 quadrants. I want to know when is the x value root 3 over 2. Well, that is my 30-degree family. So what is the 30-degree angle in the first quadrant, that's pi over 6, and a 30 degree in the fourth quadrant is 11 pi over 6. So I actually get 4 answers here again, 0 pi and pi over 6, and 11 pi over 6. All of those, if they were substituted back in, would give me an answer of 0. Let's look at our fourth example. Cosecant squared of x plus 3 cosecant of x plus 2. Well, I could try to move the 2 over, but I can't combine these because they're not like terms. And then I could factor out a cosecant, but it's not equal to 0, and you never want to do any factoring if it's not equal to 0. So what I'm going to think of, and if you remember what we did for our simplifying, if you can't see right now that I can factor this, I'm just going to call anywhere I see a cosecant in a. So this would be a squared plus 3a plus 2. So hopefully it's a little bit easier here to see that this can factor to a plus 2 and an a plus 1. And that's what I'm going to do here, but instead of a, it was cosecant. So cosecant of x plus 2, cosecant of x plus 1. And again, if you can't see factoring with all the trig functions, I always suggest using a's and b's to make it a little bit easier. So again, I have two things multiplied equal to 0, so I can use the zero product property, which means I'm going to set my first term, or grouping of terms, equal to 0, and then do the same for my second. I'm going to solve each one individually. So here I'm going to get cosecant of x equals negative 2, and then I'm going to, again, I don't like cosecant, so I'm going to write it as its reciprocal, which means I have to take the reciprocal of the other side. So, again, I'm solving for x. So this is x is equal to the inverse sine of negative 1/2. Okay. So let's think about what that means. I'm asking, when is sine a negative 1/2? Well, sine is negative in quadrants 3 and 4. And when sine is negative 1/2, again, that's only down a little bit. So this is my 30-degree family. So that means x is going to equal, in the third quadrant, it's going to be 7 pi over 6, and in the fourth quadrant, 11 pi over 6. Okay, so those are two of my answers from the first part. If I set the second part equal to 0 and solve for x, I'm going to get cosecant is equal to negative 1. But I don't want that. I'm going to take the reciprocal. The reciprocal of negative 1, because remember this is negative 1 over 1, is still negative 1. So if I think about it, when is sine a negative 1? Well, sine is negative in these two quadrants, but the only place it's actually a negative 1 is right down here, because remember this is 0, negative 1. So I'm going to get the answer right here is 3 pi over 2. So sometimes we don't get two answers, we might just get one. So we're going to get three answers for this: 7 pi over 6, 11 pi over 6, and 3 pi over 2. And let's look at our last one. Cosine squared x plus sine x plus cotangent x tangent x. So this one is really complicated. There's not even any numbers, but I have, what, 1, 2, 3, 4 different trig functions. So we're going to have to do some of our identities to help simplify this. So hopefully you recognize that cotangent of x and tangent of x are reciprocals. And anytime you multiply reciprocals together, because remember I could rewrite this as 1 over tangent, I'm going to get 1. So this is really just cosine squared of x plus sine of x plus 1. Equals 0. Okay, but now, again, I can't factor it, because if I actually wrote this out, let's say I'm going to call cosine A, and I get to sine, so that's B. I can't really do anything with that. It'd be nice if these were all in terms of A or all in terms of B. So if I see I have this cosine squared, well, if you remember from our Pythagorean identities, cosine squared is the same thing. So this is the same thing as 1 minus sine squared x. So plus sine of x plus 1 equals 0. Alright, so let's combine some like terms, put it in standard form. So we're going to go in decreasing order. So I'm going to do negative sine squared x plus sine of x, and then 1 plus 1 is 2. Okay. I don't like to factor, because if you look at this, I have negative now. I'm going to call sine, well, I guess sine was b, so I'll do negative b squared plus b plus 2 equals 0. Now this is something I can factor, but I don't like to factor with my lead coefficient negative. So if you remember, I can multiply everything by a negative 1, which just changes all of the signs. So that's what I'm going to do here. This is going to become sine squared x minus sine of x minus 2. Now I can try to factor this. Okay, and again, if you need help with that, I know I'm going to get a b and a b. I could do a negative 2 and a positive 1. This will multiply to give me a b squared, a negative 2 at the end, and add to give me a negative 1. So I'm going to get sine of x minus 2 and sine of x plus 1. So I'm going to set each part equal to 0. I'll do that right here. Sine of x minus 2 equals 0, and sine of x plus 1 equals 0. All right, so let's kind of think of these separately up here. So if I work on this one first, that's going to give me sine of x equals a positive 2. This one is going to be sine of x equals negative 1. Well, we just did this one a second ago, so let's kind of do this one first. So I know this is inverse sine of negative 1. Sorry there. So again, when is sine a negative 1? It's right down here, so we're going to get x is equal to 3 pi over 2. All right, so this is asking, again, solving for x. X is equal to the inverse sine of positive 2. So they want to know, when is sine a positive 2? Well, sine is positive in these two quadrants. But in a unit circle, the largest any one of our our sine or cosine get is 1. Right here, this is the largest that sine will ever become. And if you remember from our sine graphs, we did something like that. Well, if you remember, when it was just standard, the highest we ever got was positive 1, the lowest we ever got was negative 1. So how can we possibly get a 2? And the answer is we can't. Between 0 and 2 pi, without any other information and any other constraints, it's not like our amplitude changed. Okay, there is no number in front of here to make this higher or lower. We're actually solving for sine of x equals a positive 2. So that's not possible. So there are actually no solutions from this one. Okay, this one gives me no solution. But I don't write no solution for the whole problem because I do have a solution. The only answer that works right now is 3 pi over 2. So anytime you're getting a sine or cosine that's not in between negative 1 and positive 1, we're going to get this no solution. Now there are times when you're going to get some of the pi over 4s, our 45-degree family, and some other answers, but this is just kind of to show you some of the different algebra that can happen. So I hope you feel a little bit better about solving trig equations and you're able to solve a trig equation within a given domain, and for us that happens to be from 0 to 2 pi.